I'm Yue Qilin. Here I'm going to show you the solution of question 1 in homework 4. Question 1 provided us the function y equals gx equals this, and ask us to find and draw a large fyy and a small fyy in terms of fx and the little fx. At first, from the expression of gx, we can draw the figure of gx. From the figure, we can see y equals -1, py equals -1 will equals px is larger than 2, because when y is equals -1, x will larger than 2. That will equals 1 minus large fx when x is equals 2. Similarly, when y is equals 0, py equals 0 will equals p x is between 0 to 1. 0 to 1 will equals large fx when x equals 1 minus large fx when x equals 0. And when y equals 2, the possibility of y equals 2 will equals possibility of x is smaller than 0. When y equals 2, x is smaller than 0 is this part. That will equals large fx when x is equals 0. We have discussed the special situation, and when x is between -1 to 0, we can get in this just in this part, x is in this part, xy meets the equation y equals -x plus 1. So we can get that little fyy equals a little fx divided by the deviation of gx and the absolution. That will equals little fx when x equals 1 minus y divided by the absolution of -1. That will equals fx 1 minus y. So as a summary, we can get fyy will equals 1 minus fx when x equals 2, and multiply the impulse function delta y plus 1. This is when y equals -1, and fyy will equals fx when x equals 1 minus y. Under the situation y is between -1 to 0, and fyy will equals fx when x equals 1 minus just this one. Large fx x equals 1 minus large fx x equals 0. Multiply the impulse function delta y, and this is under the situation that y equals 0, and large fx x equals 0, multiply the impulse function, and this is under the situation y equals 2. And also in other situation, fyy will equal 0. Now we got the expression of little fyy. Now let's go into solve the expression of large fyy. Now we have got the expression of fyy. We need to find out large fyy. When y is smaller than -1, we can easily get that large fyy will equal 0, and when when y is between -1 to 0, we can get the large fyy by integral small fyy from the -infinity to y, and that will equals -infinity to -1 fyy, not plus -1 to y. That will equals 1 minus large fx2. In the second equals fx1 minus y from -1 to y. And the final answer will be 1 minus large fx when x is equal 1 minus y. So when y is between -1 to 0, large fx will equals 1 minus large fx when x equals 1 minus y. And when y is between 0 to 2, it will equals 1 minus fx 0. And when y is larger than 2, it will equals 1. Now we got the large fyy. And from the expression of little fyy and large fyy, we can get the figure of these two functions. And this is the solution for question 1.